There is a handful of different phenomena in the entire universe that can actually produce ridiculous amounts of power. So much power, as a matter of fact, that you can easily see these events from as far as the edge of the observable universe. But when it comes to some of the most powerful events out there, the events representing the most powerful explosions in the entire universe, there's really only one phenomenon that the scientists are trying to understand really well, figuring out how it works, what exactly causes it, and what other additional effects it might produce. We're talking about GRBs, or gamma ray bursts, especially the ones that usually last for a much longer period of time. Events so powerful that even today, scientists are having trouble explaining them, especially after the one detected in 2022. The event today referred to as both brightest of all time. Such an extremely powerful gamma ray burst that it ended up blinding some of the satellites in orbit and produced observations we've never seen before. You can learn more about this in one of the videos in the description. But the thing is, even today, it's not entirely clear how some GRBs are formed, what exactly happens to produce these events, and how exactly all of this ends. Although we obviously have some ideas. For example, what you see right here is an overview of a typical gamma ray burst. You have two extremely powerful jets coming from two directions, passing through a lot of gas which then illuminates the night skies, but in essence starting with a star that's about to go supernova or is unstable enough that it's no longer able to sustain itself and has to essentially collapse. And so for the most part, when it comes to these very powerful gamma ray bursts, it's always been assumed that there is maybe a black hole or some kind of a neutron star involved on the inside. Or in other words, right at the center of the star, the core collapses either into a neutron star or some kind of a black hole, which then somehow produces these very powerful bursts headed in two directions. And this by itself makes a lot of sense and does have quite a lot of evidence, but in the last few years, a lot of unusual GRBs have been discovered as well, including the ones lasting much longer than 2 seconds, and potentially involving other objects such as maybe colliding neutron stars. And in some cases, some of these GRBs seem to last way too long. For example, one of the events detected back in 2010 lasted for nearly 28 minutes. And that is way longer than anyone expects and was very difficult to explain. Here at first the scientists thought that maybe it's some kind of a comet falling into a neutron star, or possibly a neutron star falling into a much larger star, shredding it apart and thus producing these effects. So basically here the explanations were kind of uncertain. Another event from 2011 lasted for 7 hours, and that one still has absolutely no explanation. And so trying to explain all of them with some kind of a one single idea has been extremely challenging. But for the most part, a lot of scientists agree that it probably has something to do with a lot of different massive stars potentially being destroyed by something else. And more importantly, potentially involving a very massive, very dense object in the middle. And though usually we assume it to be some kind of a black hole, here the scientists believe that maybe, just maybe, it's something a little bit more extreme. Yeah, that's right, more extreme than a black hole. A ridiculously powerful magnetar. Okay, cool. But what does any of this have to do with the topic we're discussing today? Well, it turns out that at least one explanation that was provided very recently, which went through a thorough analysis of what actually happens to these magnetars as they're produced inside these stars, discovered that they actually might produce something super weird. A kind of a relativistic blade that literally splices through everything it passes through. Okay, for the lack of better words, an actual lightsaber. Or basically a spinning lightsaber that spins around the magnetar, cutting through any matter it passes on the way. Although luckily for us, or I guess luckily for anything in the vicinity, it doesn't seem to last for a very long time. But nevertheless, this is still a very intriguing proposition and something that does have a chance to explain a lot of different phenomena. And so, hello wonderful person, this is Anton. Let's discuss these unusual relativistic blades or plasma blades, potentially produced by various magnetars as they form inside the exploding stars, and discuss a few more details discovered in this recent paper. And well, to begin, all of this essentially started in order to try to explain these longer gamma ray bursts observed by many different studies. They really made no sense whatsoever, unless something unusual was formed inside the star. And in this case, these are usually really massive unstable stars, such as the famous Wolf-Rayet stars, which represent these really active massive stars expelling a lot of matter around them, producing these beautiful nebulae in the process. This is WR124, and this is actually an image taken by the James Webb not so long ago. And today it's believed that pretty much all Wolf-Rayet stars, because of their total mass, will most likely go through supernova, producing either a neutron star or a black hole, but most likely in a somewhat dramatic way. So basically the neutron star or the magnetar is going to form first on the inside, and it's then just going to destroy the rest of the star, piercing through the star in the process, with the star then either collapsing or exploding in the process. But instead of focusing on black holes forming inside of them, here the researchers focused on neutron stars, and specifically they wanted to see what actually happens if it's a magnetar. The super powerful magnet, the most powerful magnet in the entire universe, suddenly appearing inside the star. And when magnetars are born inside various objects, they're surrounded by a lot of chaos. First, obviously, they're extremely dense, so they have a lot of gravity, but this gravity is counteracted by a very powerful magnetic field and very intense radiation that tends to pull things away from the star. And so there's this enormous mixture of stuff going on very close to the magnetar, with things moving around in extremely unpredictable ways. And yeah, all of this is happening inside a massive star. And so while the magnetic field starts to whip around all of this plasma on the inside, based on modern observations, we know that at some point we have these two jets forming on the polar edges of the magnetar or the neutron star, basically punching their way through the star, which we then receive as a gamma ray burst. But while looking at magnetar's properties, the scientists behind the recent paper realized that a typical magnetar also has extremely powerful emissions coming from the equatorial regions as well. And so here, if we try to imagine a typical neutron star right at the equator, which I guess is kind of difficult to visualize, but I mean it's very similar to planet Earth, because of the tremendously fast spin and because of the powerful magnetic fields, it actually forms these intense bursts of radiation that potentially resembles something like this. In this case, produced by the combination of centrifugal forces from the rotating star and of course ridiculously powerful magnetism. And though by itself this was already pretty intriguing, it became even more intriguing when the researchers looked at the amount of energy all of this was producing. By running this through computer simulations, they realized that the radiation here very likely moves at almost the speed of light, and it seems to carry more energy than an actual supernova explosion. In essence, literally producing what the scientists refer to as laminar jets, or more specifically, relativistic blades. A fast-moving, extremely powerful, extremely energetic plasma that moves away from the neutron star ridiculously fast, cutting through everything on the way. And obviously, cutting the star in the process as well. So it basically acts as a kind of a plasma saw, or I guess a plasma blade, moving around the neutron star and dissecting everything in the process. Obviously shredding the star in half, but even going beyond the star up to about a distance of 4 star radii. And anything on the way of this blade gets shredded as well. Intriguingly, as it travels away from the star, it even picks up some of the star material, adding to the total energy, essentially becoming extremely powerful just as it leaves the star. But this process of shedding also creates huge amounts of instabilities within the star, eventually leading to its collapse or its explosion, with the simulations suggesting that these blades can most likely last for approximately 4 seconds. So basically traveling for about 4 light seconds away from the center. And so if there is, for example, some kind of a planet on the way, it's done. It's going to be completely shredded. I mean, it's unlikely to be so close to the star, but you never know. But more importantly, by conducting the simulation and explaining these unusual formations, it potentially explains some of these longer-lasting GRBs, the ones that usually last for at least a few seconds. Because in this case, the simulations do actually present very similar results in terms of gamma ray emissions. Here, the emissions are coming from the unusual blade produced by the magnetar, and not necessarily these polar emissions that we usually expect from gamma ray bursts. But obviously, because this is just the first such proposition, here the researchers still need some time to try to figure out how all of this evolves over time and what happens to the star afterwards. More importantly though, it's not in the realm of science fiction. As a matter of fact, we see much smaller events or much smaller phenomena happening around various pulsars out there. And one of the most famous examples is right here in the Milky Way. the crab pulsar. It actually produces these equatorial winds, even though it's not a magnetar and just a typical neutron star or a typical pulsar. But if this was a magnetar, these emissions that you see right there, producing equatorial winds, would be dramatically more powerful. And though normally they actually produce what's known as the pulsar wind nebula, if they become fast enough and form these unusual laminar jets, the resulting effects are going to be way more extreme, cutting everything on their way. But I guess the next more important question is, okay, but is this going to happen anywhere near us? And the answer to that might actually be yes. With one of the most likely candidates for this being the iconic star at the Carina we've discussed not so long ago in a video you can find in the description. And so this star actually sort of matches the properties we expect from typical stars that should be forming a lot of instability on the inside and potentially form some kind of a gamma ray burst in the process. With the second candidate being the star nicknamed Apep, after the Egyptian god. Here, this is also a Wolf-Rayet star forming very unusual patterns, suggesting potential instability in the future and suggesting a potential gamma ray burst that might even head toward us. This one is actually most likely to go supernova first. Lastly, we have the Wolf-Rayet star known as WR104, producing similar effects, but much farther away. And so all three of these stars could be hypothetically producing these longer gamma ray bursts, and possibly as a result of these unusual plasma blades. It's not going to happen anytime soon, but it's still a possibility. And if the authors behind this paper are correct, it might also finally help us to explain a lot of other similar phenomena as well. For example, F-bots or fast blue optical transients, and various superluminous supernova. A lot of these phenomena could be related to what's actually happening inside these exploding stars. So yeah, basically some kind of a lightsaber cuts through them, producing all of these emissions. But at least for now, this is just, of course, a hypothesis and needs more studies and more verifications. Either way, quite exciting and definitely quite intriguing. But we'll discuss more once there are some updates or additional explanations. In the meanwhile, check out the previous video on the so-called brightest of all time gamma ray burst that still makes absolutely no sense. And this actually only happened like a year ago from when I'm making this video. Anyway, on that note, thank you for watching, subscribe, we'll discuss updates in some of the future videos, and maybe support this channel on Patreon by joining channel membership, or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.